Hello, so we're just about to start our second webinar of the week, Intelligent Buildings and Smart Sensing, what to consider in design. If you have any questions, feel free to ask them throughout the webinar and we'll come back to those at the end. So without further ado, I will pass you over to Alan, who will be presenting the webinar.
Hi everyone, welcome. This is the second one this week. I thought let's start this webinar with a look at what makes a building intelligent. So if we look at the evolution of buildings, we'll have seen that in the past and currently, and probably well into the future, we can consider some buildings as automated. So automation is the process of a building doing things without direct instruction or human intervention. So there are sensors, maybe in the room you're sitting in, over by the door. There's a sensor for the climate control or heating control. And that's monitoring the ambient conditions and keeping it at temperature set point so that you and I don't have to. Maybe in the room you're in, if you're in an office, there's a sensor in the ceiling, and that switches the lights on and off without the intervention of you or I, so that it's automating that building service. The thing about these products in these buildings is that they're not particularly intelligent, and they usually don't talk to each other, but they do react and monitor the conditions and change them automatically. But as technology improved, as buildings started to need less management and less maintenance staff, really what came next was the need to optimize the building. And what we see here is a more smart building, a more intelligent building. But what we then see is that we're still providing these sensors, these services in silos. So the climate control guys are still selling their products. The lighting guys are still selling their products into the building. Maybe the security systems, the fire alarm, etc., are all supplied in silos separately. And to optimize the building, to get those services to talk to each other, we then need the services of a systems integrator. What the systems integrator does, they act like a technical marriage counselor. They get all of these different silos, all of these different building services to talk to each other. But that in itself adds another layer of complexity and another layer of cost. And that's how a lot of buildings, the first two, the automated building and the smart building, are designed today. And you'll recognize those if you're in any of the services industries or any of the building industries. You will recognize one or either of those, or maybe a hybrid of the two. But where the discussion is now going is to a more intelligent building, where the building services are working interoperably and they're working together for the benefit of the people using the spaces. So that sensor by the door that's measuring the temperature, that sensor in the ceiling that's measuring the light level or occupancy, the room booking system, the fire, the security, all of these different services are working together seamlessly and interoperably for the benefit of the building, but also for the benefit of the people using the building. So in these types of buildings, we're now starting to see that the room can be set up for me, to my personal preferences, based on past usage, current usage, and maybe during the room booking system, future usage. And then if somebody else walks in, like Jazz sitting next to me, that room will be set up for her rather than me, because we're all different and we have different needs. So there we see automated buildings, fantastic, taking the need away of human intervention for the building services. Smarter, more intelligent buildings, but still provided in silos, still the building services provided separately with the need for an integrator. And then moving forwards into the future, where the products themselves, the services and solutions themselves are now starting to talk to each other for the benefit of users. So again, if you're in this building trade or one of the building services trade, you'll know that getting anything done is quite complicated, because there are some people at the beginning of a process that want to build a building, design a building, invest money in a building to attract tenants or move their own employees in. And then they go to the experts, the architects, the building consultants, and they try and turn these ideas into actual design. So we call that going from insight to design. And once that design is pretty much complete, they go out into the specification stage, where sometimes we get involved, hopefully, where we help these guys make the right decisions from a lighting perspective, but also from a building and well-being perspective. And then it goes out to tender, and that's when things can go wrong, because the time scale between the original idea and the start of the build can be quite long, so budgets can get squeezed. And that's when it's quite common for those original ideas that would have benefited the end users quite often get taken out. So our challenge going forward, considering where we're moving from automation to different silos in buildings to a more intelligent system that is designed for the benefit of the people using the space, is can we get involved early enough in the process of design? And can we ensure that at least those aspects of the design that positively impact health and well-being are maintained throughout the life cycle of the design build process? And I would argue that I get those people with the idea of building the building, for sure, are thinking about who's going to use it, which tenants they want to attract, and how long they want to keep their tenants, and what kind of tenants they are. So they're thinking about the users of the building right at the initial stages. And it's after that that we start talking more about the building itself rather than the people using it. So that's the change, and that's what I would ask you to think about going forward, is how to make sure that everything we do really positively impacts the people using the spaces. So for the purpose of the rest of this webinar, we're going to talk about three things. We're going to talk about energy management, how sensing impacts energy management, how we can optimize spaces to work to their full potential with maximum energy saving. We're going to talk secondly about efficiency, not just about the efficiency of the building, but the efficiency of the people using the building, and even a little bit about predictive maintenance. And then the last, but certainly not least, is how those technologies and how those buildings impact well-being, and we'll remind ourselves about the 10 concepts of the WELL standard. So the first one, energy management. So what we saw earlier, certainly in automated buildings and smart buildings, is that there are sensors everywhere, and lighting sensors these days, especially if a building is going for LEED or BREEAM, are the most common. And therefore, they're best placed to give us occupancy data. So really understanding how that space is going to be used is the key to optimize it in terms of efficiency. So we can use those sensors to make sure that there's better productivity, better efficiency in terms of energy saving, energy management, but also the people using the spaces. We can find out why spaces aren't being used and correct that. Even if spaces aren't being used, sell off or rent out that part of the space. And certainly if we know how spaces are being used, then we can improve the well-being of the people using the spaces. So this is a great slide if you want to explain to people how this process works. The first thing to do, as I mentioned through the lighting sensors, is to collect the data from the space to understand what's happening. If we don't understand what's happening in the space, if we don't have the data, then we can't do anything about improving that space. The next part is to refine that data and create value from it. Data in itself is not much use. We need to use our expertise to refine that data, to create value from that data, and then make sure that we utilize that data to interact with the other building services so that the building services are working collaboratively to improve the energy saving, to optimize the building services, including the lighting, to provide a better user experience and to positively impact well-being in that indoor environment. So to recap, it's about sensing the environment. It's about creating value from the data we collect. It's about getting that data and using it to interact to the other building services. And when we've done that, it's about making sure that all of those building services are working together to positively impact energy management, energy saving, optimize lighting, provide a better user experience, and improve well-being. So to give you an example, real life examples, here we talk about some university projects where they're actually utilizing lighting sensors and collecting occupancy data and using that across the building services to reduce energy consumption. So these days, probably wherever you are in the world, people are trying to save energy. With the advent of LED, lighting uses less energy than ever before, which means that the climate control system is now one of the greatest users of energy in buildings. So the targets, for example, I can give you two cases of quite huge campuses. They're required to halve their energy bill by 2025 in one instance in Sweden, by 2030 for the one in the UK I could mention. As I said, they're using the lighting sensors to collect occupancy data across the building services. And this is a real example. This is actually from Bristol University in the UK. So if I tell you that, I guess you know that most times building services go into a building, including lighting, it's commissioned, it's programmed, and then it's left. And it's not particularly optimized for the ongoing usage of the space. So in this case, using our Helvar Cloud Gateway, we collected the data of how certain spaces were being used on this campus. And we can see the one on the left-hand side was one room where the PIR off time, was set to 30 minutes. We then collected the data and recommended that timer be reset to 6 minutes, and nobody would know the difference. Hopefully nobody would see the difference. That turned out to be the case. And in that case, that one room saved nearly 84 hours of light on time in 1 month. On the right-hand side, you'll see a different room, a different timer setting, and a different reduction in light on time. But those are significant energy savings. And if you start to use that across the building services, not just for lighting, for climate control, and across a whole building and across campuses, the savings can be absolutely huge. So it's quite possible now to use historic data, dynamic data, to proactively set up the room to maximize its efficiency and energy saving. So that's the first part done. Make no apologies for smiley faces in PowerPoints. Now we go on to efficiency. And it's the same thing about making the building, the room, the space within that building the most efficient. It's still about collecting the data, knowing how the space is being used, creating value, making sure that the sensing technologies are interacting across the building services for the maximum impact in the space. So we already mentioned that one aspect is energy saving and energy optimization. The second part is, once we understand how the spaces are being used, so we've collected that occupancy data, we can present it as data, we can present it in a heat map on a floor plan, as you can see here. And we can use that to really understand how spaces are being used. So are certain spaces in the building used more than others? Why is that so? Is it because the lighting is better or worse? Is it because the temperature is too warm, too cold? Is it because there is more natural daylight and people like it? Is it because it's the canteen and people like to hang out there? But really understanding how the space is used allows us to optimize those spaces for the benefit of the users. And then really important now, and this is a message that's slowly starting to get out into the world, is that these days sensors are digital, and there is no reason that one digital sensor in the right place, in the right scenario, can't be used to optimize the other building services So then we get rid of this silo mentality of having one sensor for lighting, one sensor for climate control, one sensor for security, and so on and so forth. So it's absolutely vital to get the message out there, to ask the question, if the sensor is digital, how can I use it across the building services? One aspect of the building, of course, is reducing operating costs to make sure that the building is working to maximum efficiency. And because, for example, our lighting system utilizing DALI and digital sensing, we can collect data from that system. We can find out how it's being used, whether there's a failure of a product, and we can do something about it. We can present that data again on a floor plan, which is color-coded, for example, or we could use it to send an email or a text to the facilities management team, which is reducing their overall operating costs, making them more efficient, and keeping the building working at maximum efficiency. I briefly mentioned earlier on about occupancy data and how to improve building performance. We're starting now to see this more and more, thankfully, in modern buildings, particularly in new builds, but we should start to see it more and more in retrofit and upgrades now. So utilizing that digital technology, that lighting sensing technology, to really understand where people are in the buildings at any given time, how long they're staying there, and how to optimize those spaces within that building to improve building performance. The other aspect of this is that once we have that data, it can be used to design better buildings of the future. So many buildings now are designed with a percentage of occupancy in mind, and those building services running full power from maybe 6 in the morning to 6 at night. Once we have the data from one building, once we understand how the building is being used, we can then utilize that data to improve things going forward. And then last but not least, improving user experience and well-being within those indoor spaces, utilizing that occupancy data, but also from the lighting system, making sure that we're utilizing the dynamic aspects of, for example, DALI. There is DALI Type 8, which is the industry standard. DALI is the industry standard for lighting. And through DALI Type 8, we have the possibility to modify throughout the day or set at different times of the day light intensity, color temperature, and color, which means that the indoor environment is replicating the outdoor environment in a dynamic and positive and healthy way. And we can take a look at how to do that later on. If I mentioned something a little bit more technical, when thinking about how to implement this in buildings, whether the building is a new build or a retrofit or a refit, it really doesn't matter today whether you're discussing wired or wireless. The outcome has to be the system which maximizes efficiency, optimizes the space for the owner and the facilities manager, and provides positive health and well-being aspects. So really, let's not let the technology stand in the way of those outputs. And from Helvar, we can certainly supply you your wired and wireless systems that can deliver all of those aspects of the building. And DALI, I'll mention again that there is only one industry standard for lighting, and that's DALI. And built into DALI is a lot of data. So we can utilize that data across all of the aspects I just mentioned, whether it's maintenance and monitoring to keep the building optimized and efficient, or getting that occupancy data to make sure that we are fully optimizing the spaces, especially if you're tenanting a building, you want to optimize that space. So that's efficiency. And lastly, we'll just touch on well-being. For those that joined yesterday, we mentioned well-being a little bit in more detail. But just to remind you, the well-being aspect is absolutely crucial. So just to remind that getting well and understanding well-being means understanding how your conditions around you, how the ambient conditions are affecting your health and well-being. And what we're starting to see now in some parts of the world, or some designers and investors, is that they're designing buildings with LEED and BREEAM or other certifications for the building. And in parallel to that, they're starting to take into consideration the WELL standard, which means that at last, we're starting to build buildings for the people that are going to be using those buildings. And to help us along, we have the WELL standard, and the WELL standard has 10 concepts. I will briefly run through them. So air, making sure that there is access to good quality clean air. Water is essential for life. So access to good clean water at all times. Nourishment, making sure that we have access to good food to keep us running at maximum efficiency as human beings. Light is absolutely essential for life, and good quality flicker-free light, preferably dynamic light, maybe using the Helvar light over time feature, which changes in line with natural circadian rhythms, the intensity and color temperature. Movement, having free movement around and encouraging people to move around to improve their fitness levels, to keep them working as efficiently as possible. Thermal comfort, making sure that the spaces are not too hot or not too cold. And of course, sensors can be used for that. Sound, it might sound strange, but too little sound, it can be just as damaging as too much sound. So making sure that sound is taken into consideration when designing the buildings. Having good materials. And of course, once you've chosen those materials, light has a huge impact on how those materials are perceived, making sure that the lights give a good color rendering index. Mind is really, I'm happy to say, coming more and more important, and that's making sure that employees, students, factory workers, whoever, can cope with the day-to-day stresses of life. And if they don't or can't cope with those day-to-day stresses, understanding where they can go to get help. And the last concept is community. So human beings are natural communal beings. We like hanging out together. So making sure that there are spaces, whether it's a kitchen area or a sit-down area, where people can just sit and talk and share experiences. And those are the 10 concepts of the WELL standard. And I would say, from experience, if you're designing a room or a floor within a building or a whole building or a campus, you can take these 10 concepts into consideration. And I guarantee if you do, you will end up with a better space than if you don't. What we can also see from a technical perspective is that I talked earlier about getting these building services to work interoperably. So, for example, if we have a light sensor, asking the question, can that light sensor be used collaboratively with the air conditioning system, the climate control system, the heating system? Can it be used to, or at least the data from that sensing technology be used to influence how those other building services are used? And the answer in many times is yes. And ideally, they would be doing that interoperably within the room itself and not via another layer of systems integration. But certainly this is an area that we're seeing huge gains on a monthly basis within our industry. Of course, I mentioned light. We're in the lighting industry, and we know that light is hugely important. Human beings are intrinsically linked to light. It tells us when we go to sleep. It tells us when to wake up. But on a more intrinsic level, on a more human level, it also affects our mood. So it's not just about the visual aspects of the light. The color temperature and the right color temperature at times of day can really affect how we feel and affect our mood. It affects more at a physiological level than a visual level. And using, for example, the Helvar system with the intelligent color feature within Designer and utilizing DALI, we really simply now can put into practice dynamic lighting in the workplace, in the learning place, or in the factory, where very subtly throughout the day we can change intensity and color temperature to really mimic what's happening outside in the natural world in the indoor environment. And again, from experience, I can tell you that those people that have put dynamic lighting into office workspace environments or learning environments, it's a completely different feeling from a fixed lighting environment. Of course, it has to be flicker free, good color rendering, but really using dynamic lighting is more natural than using fixed lighting in indoor spaces. So check out the Helvar Intelligent Color and Light Over Time features. The applications that we can really start to see that dynamic lighting has an impact is, for example, in healthcare environments where we need people to relax and recover. So we would have a lower intensity, warmer light color temperature. In the office environment, to energize employees with higher intensity levels with a more cool white color temperature, which is more energizing, just like a summer's day is more energizing. General activities and tasks, so making sure that we've always got the right light level for the right task. So, for example, using Helvar sensors, which have constant light control to make sure that we always have the right lux level on the working plane. And we can modify that throughout the day based on ambient light conditions. And then, of course, for productivity, whether it's in the factory environment or whether it's in the learning environment. So making sure that we have enough light to allow people to work, and making sure that light intensity is modified to the ambient conditions, but it's a cool white to energize the people who are trying to learn or trying to produce whatever they're trying to produce. So the message here is that fixed lighting is a thing of the past. The technology allows us to modify intensity for task lighting, for example, but also color temperature to affect mood and in different applications. And again, have a look at the Helvar system with its intelligent color feature, and take a look at DALI, which I remind you is the only industry standard for lighting. So the challenge is, I guess, to ensure that we can link building efficiency, building optimization, and more importantly, the well-being and user experience of those occupants. We have the 10 concepts of the WELL standard to help us and remind us of what those indoor environments should be delivering to us. And then we can see that through intelligent lighting, through the use of industry standard protocols, we're able to provide that light part at the very least of the well-being concept through intensity control, color temperature control, and color control. We can do all of that by making sure that the building services are working interoperably. We can guarantee the quality because we're only using industry standards. And through use of intelligent lighting systems, we ensure that the sustainability of that building for the benefit of those users is guaranteed going forwards. So we've covered today energy management very briefly. We've covered building efficiency and human efficiency within the indoor environment very briefly. And we've covered well-being optimization. And what's really great is that we don't need different technology to provide these things. It's all from the same building technology. So it's all about turning everyday places into brighter spaces, of course. It's about using intelligent lighting and smart sensing. But mostly it's about getting people to ask different questions. So how can that smart sensing work interoperably with the other building services? How can that smart sensing positively impact the health and well-being of the people using the spaces? So that brings this webinar to a close, and I'm here for any questions you might want to ask.
Thank you, Alan. Let's see what questions people have. So, there's a great one here. How can people be better when it comes to designing buildings?
I think that the design of buildings is changing. So I've been in this industry for quite a while, and it used to be quite conservative, and there was a standard way of working. So lighting designers did what they did, MEPs did what they did. I think with the better communication and better education, the decision-making process of what lighting and what building services is happening more at the beginning of the process now. So investors, architects, designers are now starting to ask the question, how can the technology that I'm paying for positively impact how quickly I can get tenants, how long I can keep those tenants, what's the tenant experience, what's the return on investment? So I think the decision making is moving towards the beginning of the process. Because I think in the past we've seen decision making and purchasing criteria separate. I think they're becoming the same thing.
Thank you. So another great question. What can we expect from technology when it comes to meeting the needs of managing a building over its lifetime?
I think the key there is to make sure that you use standards within buildings, get away from using proprietary systems that lock you into one supplier forever. So the industry standard for lighting is DALI. If you use DALI, then you're guaranteed of the sustainability of the system going forward. The other aspect is that if the system is digital, then take the data from that system to make sure that your building is always optimized going forwards. If you don't do it at the beginning of the process, then at least make sure that the systems you're putting in the building can be upgraded to allow you to take that data later on.
Okay, a great question from Yusuf. Can Helvar products be interfaced with climate control?
Yes, there's a number of different ways of doing that. Of course, one is a simple switch, a relay output. You can do it via, if there's a building management system in place, if that's BACnet or, for example, Niagara, you can provide the data from the router system up to the Niagara or BACnet system and do it that way. So there's many different ways of doing it.
When will the wired and wireless hybrid network solution be available?
From Helvar, that's very soon. So we currently have Active Ahead and the router system, RoomSet, and other things. So I believe the target is to have that connected together this year. And if I remember, it's the second half of the year.
How many percentage of the buildings are digitalized?
That's a really hard question for me to answer. And I'm not going to answer it because I don't know.
Yeah, no problem. Then we've got, as a programmer, I'm becoming into projects after the planning stage, primarily at the installation stage. What is your opinion on programmers being involved early on in project planning, and what are the benefits of being involved earlier?
That's really great question. I think too often the commissioning or programming of that comes as a surprise.
Yeah.
To the people turning up on site. The move certainly from Helvar is to make sure that we collect that data earlier on in the process. We're also looking at other technologies like BIM, like digital twinning, like other technologies to make sure that we have the installation documented earlier on in the process. So maybe for now, sorry for that, you have to go and just commission it, but in the future I'm pretty sure that will get better.
Another great question here. Are certain stakeholders becoming more important in designing new buildings than before?
Absolutely. So I'm talking to, for the first time in my life, I'm talking to investors and developers about what lighting they should put into their building at the design stage to make sure that their employees, their tenants, the users of the building have the best experience. Now, in the past, that was what lighting designers and MEPs did. But now really talking to investors, because they see that lighting has a huge impact on productivity, on learning, on the well-being of their staff, but they're also interested on how the technology can be utilised to work interoperably across the building services. And that's because the WELL standard is now being run alongside LEED and BREEAM, which is at the beginning of the process.
Another question here, can Helva sensors collect data through Bluetooth?
Can Helva sensors collect through Bluetooth or LAN? Certainly through LAN, yes. The Bluetooth part, I'm not sure about. I'd need to get back to you.
Okay, another question here. What are the differences between an old building and a new build or renovation project when it comes to intelligent buildings?
Actually, there should be no difference whatsoever as far as the user is concerned. As far as the designer is concerned, they need to take into consideration whether they can change the wiring. Are they running new wiring? Can't they change the wiring at all? So that's where the earlier question of when will the wired and the wireless systems be joined together becomes crucial, because for the person designing that system, that there should be no difference between the wired and the wireless side. So it's really about are they able to pull cables or use existing cables for the system?
Great, and a final question here. Are there any plans to have RGBW control to balance melatonin and serotonin levels?
Well, the answer is yes, but I'm not sure whether that's a technical question or an industry question. But certainly, if you look at the WELL standard and the lighting part of the WELL standard, you'll see quite clearly there that it's about mixing intensity, color temperature, and looking at task lighting, but also looking more at equivalent melanopic lux levels, which are a more natural way of providing intensity and color temperature in the workplace.
Great, so that's all for questions now. So we hope you enjoyed the webinar and would like to thank you for your time. If you have any further questions, you can contact us at marketing@helva.com or get in touch with your partner managers. We hope you can join us on our third webinar on Active Head tomorrow, which covers the wireless side, which is the same time at 9 AM GMT. We have some really great things to say, so we look forward to speaking to you tomorrow. Thanks again, and we hope you have a great rest of the day. Thank you.
Bye.
Bye.